This is question 14 for the practice final. The first thing on this question is you probably notice it looks different than what's on the left. In the left, we have trinomial over trinomial divided by two binomials. What I did is I just initially wrote this, which says our denominator initially, our x squared minus 1, is put in the numerator. Our x minus 2 in the numerator gets put down to the denominator. And our division symbol gets changed into multiplication. So I kind of use this little symbol where I show that these are being swapped. And that's just me because when I first write the problem, I don't want to write a problem just to rewrite it again. That's just a me thing. So going through this, we're going to look at all four pieces. So we have four different pieces that are going on here. The first one is the trinomial in the upper left. In this case, we have a negative c, right? Which means we're going to be looking for the difference of the numbers. So what numbers multiply to be a 6? Well, there's 1 and 6, and there's 2 and 3. So which combination of this will create our difference? Well, let's see. If we were to take these, and notice that our x is positive. Since our x is positive, if b is positive, our larger numbers, our bigger numbers, will also be positive. Since this is difference, it means the smaller ones are going to be negative. So we end up with 5, and we end up with 1. Well, there's our answer, our 1. So what we're going to do is we're going to create some binomials with this just above it. And our binomial is going to be x minus 2 and x plus 3. And again, we can double check to make sure that works, because if we say x times x, we get x squared. 2 times 3, negative 6. And that's just, again, quick check. Our denominator has a positive for our c and a negative for our b. So both numbers are the same, same. And then we think of numbers that multiply to be a 1. Well, there's only one. 1 times 1. And since our b is a negative, they are negative and negative, which gives us a negative 2. And there's our answer. That's our b. So same thing, we're going to create two binomials. X minus 1, x minus 1. And we're going to set that aside. So I'm going to highlight real quick what our current answers are, just for clarity's sake. The next thing we're going to look at is this one right here, the upper right. That is a binomial. So because it's a binomial, we're going to ask ourselves, first, is it a difference of squares? And it is. And we know that difference of squares means a squared minus b squared is a plus b, a minus b. In this case, our a is simply a x, and our b is a 1. And that's the best we got right now. So again, I'm going to highlight our current answers. Now the denominator in the lower right doesn't have a difference of squares. It's not a difference of cubes or sum of cubes. It's nothing. So this one's already done because it's prime. Now, since this is multiplication of a fraction, we just have to look at each term in our numerator and see if there's a copy in the denominator. If they are, they cancel into a 1. Going from left to right, we have a x minus 2. Well, we have an x minus 2 in the bottom here. So these two cancel out. We next have an x plus 3. There is no x plus 3 in the denominator, so we stop there. The next number is x plus 1. There is no x plus 1 in the denominator. And then we have x minus 1, which we do have in the denominator. So we will cancel our first and our first, and there they go. This leaves us with x plus 3, x plus 1 in our numerator. And then in our denominator, we are going to have simply x minus 1. And that's as far as we can go. You could technically, if you wanted to, go and distribute this again and do x squared and then, let's see, x squared 4x plus 3, but that would actually make the question more complex and is not going to simplify it. So when we simplify, we want to keep it as small as we can. So this would be our answer in this case. All right.